So this is a video about how to do the arrow diagrams that we've been doing in class. I'm in the advanced chemistry section where I put some examples up as material today. So let's pull that out and we'll take a look at a sample problem, and I'll go kind of slowly and make sure we know what we're doing. So we'll do a kind of a larger one. We'll do bromine. So if you go to a periodic table, you'll see that bromine has 35 electrons. Trust me, this thing's going to open in just a minute. There it is. So bromine's over here. Notice that it's blue. This would be a good time to point out that there are two elements that are liquids in their normal state. That's what blue means. Bromine's one of them, and the other one's mercury. So those are the only two elements on the periodic table that are normally liquids in their normal everyday state. So anyway, bromine has 35 electrons. So if we're going to put the electrons in for bromine, we'll go ahead and put some arrows in. Now remember, you get arrows from this insert menu, special characters, and click on special characters, not Latin, and click an up arrow and a down arrow, and that'll put them in your document somewhere. And then we'll just cut those, or copy them, actually cut them, and put them in the appropriate place for bromine. So the 1s sublevel holds 2 electrons, and the 2s sublevel will also hold 2 electrons. Getting a few extra spaces in there, so we'll just consolidate that a little bit. Okay, then the 2p, normally you'd put these electrons in one at a time because the electrons go into separate beds, but we know they're going to be full at the end, so I just went ahead and put them in that way because of the cutting and pasting. Okay, then, check this out. Then we have 3s2, 3p6, then 4s2. Notice that 3d follows 4p. You know that from the diagonal rule. And after 3d comes 4p. Oh, but at 4p, I think I better stop and count, I guess. We've got 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30. We're only going to 35. So I'm going to do these one at a time. Because so there's 33. And remember, the electrons go in one at a time before they begin to pair up. So when they pair up, I'm copying and pasting here, they'll look like this. And so that is the electron orbital notation for bromine. Now if we do the full electron configuration, we would write down what's in the 1s. So what's in the 1s? 1s has 2 electrons in it. Then the 2s has 2 electrons, and the 2p has 6 electrons. So you can see that right here they are, 2, 4, 6. Then after the 2p fills in the 3s, so 3s, and it holds 2, and then 3p, and it holds 6. Then after the 3p is the 4s, right here. Then it will be followed by 3d with 10. So 4s, it has 2. Then the 3d has 10. And then after 3d is 4p. Now normally the 4p would hold 6, but in this case we only have 5, so you end it with 4p5. Alright, now that's the full electron configuration, shows everything. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p5. Today in class I was mentioning the diagonal rule is really on the periodic table. So if you look right here, you have 1s, and we're going to go to bromine, so I'm just going to show you how to go through this. 1s, 2s, 2p's next, and then 3s, and then 3p, and then 4s, followed by 3d, and then 4p. Notice bromine is the 5th one over here, so it'll end in 4p5. It ends in 4p5 because it was the 5th one in the 4p region. Also, while we're talking about this, notice that this area here is 2 atoms wide. That's for the s sublevel. This d region is 10 wide because the d sublevel holds 10 electrons. This region here is 6 wide because the p sublevel holds 6 electrons, and this region at the bottom is 10 wide because that region holds, 14 wide, that region holds 14 electrons. Notice also that helium is kind of in a weird spot here, and there's a hole over here. So really, by electron arrangement, helium should go over on this side. But it doesn't fit there chemically, so chemically it matches these guys better, so it gets put on the right side. Stepped up to shut the door, got a little noise going on in the hall. All right, so that's about how to do. I just want you to know that the diagonal rule is actually on the periodic table. So it's 1s, 2s, then 2p, then 3s, then 3p, and 4s, and 3d, and 4p, just going in order, 5s, 4d, 5p. When you get over here, 6s has this little special figure right here. That means to go down here. Because really, these rows down here should be inserted right here. But that would make the periodic table really wide. And so we don't put them there, we put them down here. Another reason to put them down here is that since this is 6s and this is 4f, the outer shell, the highest energy level, is what determines properties. And so these, since they're 4f is 2 levels below the 6th energy level, these guys have all very similar properties. So it's another reason it makes sense to group them all together down at the bottom. So anyway, 6s, 4f, 5d is next, and after 5d is 6p, and then 7s. Then there's another one of these fancy little characters right here. See that double cross thing? That means go down here. So 5f would fit in right here in this space. Then 6d, then 7p, and that's all we have right now for elements that we know about. Okay, so that was a little overview on the periodic table. Now let's go back to the electron configurations. So the outer shell is the highest value of N. So if we look down here, the highest energy level, that's 1, that's 2, that's 2, that's third energy level, fourth energy level, third energy level, fourth energy level. The fourth level is the highest one. So that means that this area, this right here, I intended to put that in pink, not this. So let's take this back out. I don't want to call your attention to that for any reason. Put that back in black. All right, and then the other part of the outer shell, in this case, is this guy, because the fourth energy level shows up in the fourth floor sunny room and the first floor pink room. Okay, so the outer shell configuration, just take this, copy it, paste it up here, delete out the part that's not really part of the outer shell, and that's how you do that part. Now the noble gas configuration involves finding the element at hand and then going up one row to the noble gas of that row. So in this case it's bromine. You go up one row, so you're on this row, go to the far right, the noble gas is argon. Argon has 18 electrons. You see them right there? So up a row to the far right, argon has 18 electrons. So you could write this. And that would cover 18 electrons. So down here, these electrons in the brackets are actually the same thing. So all of this is the same thing as saying AR up above in brackets. So the stuff in green down here is this up here. They mean the same thing. All right, so now after you know you've done that, that's 18 of the electrons. These were not part of argon, so you copy them, and they just go after the symbol. So this is a shortcut way that's used pretty often to write electron configurations. Instead of writing all this stuff out, they put argon, then whatever's left over after the argon electrons would get added to the end. So bromine has 35, argon has 18, so these 17 would still need to be added on to argon. If you're doing, I'm going to do one more element, I think, for electron configurations, and we'll run through everything on for that element. So this time we'll do a bigger element. I'll copy all this since I already got it done anyway. So we'll do the full electron configuration for, we'll do lead, because some of you guys are into heavy metal, I know. So here we go, lead. Lead is PB. Let's don't do it in pink. Lead is a kind of a gray metal, so we'll do it in gray here. Okay, so PB. So it's going to be 1s2, 2s2, and all that stuff, except here you're going to have 6. All right, then after for 4p, if we go back to our periodic table, after 4p was here, then 5s here, then 4d, then 5p comes next, then 6s. So I'm going to go over up through 6s, and we'll come back and check again. So for lead, 4p, we'll do the rest of it in my gray color. So we'd have 4p, 5s. 5s holds 2. Then 4d was next, and it holds 10. Then 4p was next, and it holds 6. And then 6s, sorry. 6s, and it holds 1. Now, it holds 2. After 6s then, go back over here, that's where we run into this little cross thing, so you come down here to 4f, then 5d. So we'll do 4f and 5d next. So we'd have 4f, and it holds 14. And in 5d, it holds 10. But it'll be full in this case. So here we go back to check again. So now we've done through 5d. We're over here. We're not quite to lead, but we're close, because 6p follows 5d. So lead has 2 electrons in its 6p sublevel. So we'll go back over here, and we'll have 6p with 2. All right, so that's the full electron configuration for lead. Now, if I wanted to do the outer configuration, I look for the highest coefficients, and you'll notice it shows up here. So that's a high one, and this is a high one. So those two are the highest levels. So I'm going to come up here, I'm going to copy it. Oops. So I copy all this. I'm going to pop it right up in here. So we paste that in. Now we delete out what we don't need, because those are not a highest energy level. Remember, these guys right here, they're 4f and 5d. That's not the highest coefficients. So take those out. So we got 6s2, 6p2. Oh, and there's 4 electrons in the outer shell. But the fact that there's 4 electrons in the outer shell shouldn't be any big surprise, because look, it's in the 4th tall column, and there's a little Roman numeral 4 right here. All right, so then if we did the noble gas configuration for lead, just as an example, we go back here, look at lead. Lead's right here. You go up, you go over to the far right. It's xenon would be the element that we use. So xenon has 54 electrons. So I'm going to write in the symbol Xe. And how many electrons did I say it has? 54. Okay, so that 54 down here, that's 30, 36, 38, 48, 54. 54 goes to right there. So all of that is covered by the symbol Xe. And then to finish the noble gas configuration, you just take what is not covered by the symbol Xe and write those out. And that's the noble gas configuration. So I hope that video helped. You have 4 in your actual electron configuration 1 is what you're going to turn in. Or I actually think it's electron configurations HC for you guys for advanced chemistry. All right, hope that helped. I'll see you next week.